What happens when engineering pushes beyond normal limits? Suddenly, we're not just talking about tools or vehicles. We're talking about machines so gigantic, they seem to defy logic. These titans of engineering don't just work on the landscape, they reshape it entirely. Imagine excavators that could swallow a house, tractors with tires taller than a person, and transporters that move entire rockets inch by inch. Today, we're diving into the world of mega machines, exploring not just their size, but the brilliant solutions that brought them to life. Let's meet the giants that are literally reshaping our world. Why build machines this enormous? The answer: necessity. When the challenge is moving mountains of earth, harvesting thousands of acres, or transporting objects as heavy as skyscrapers, only mega machines will do. In mining, a single person with a shovel could work for years and barely scratch the surface, but a giant excavator can move thousands of tons daily. These machines multiply human effort, making the impossible possible. Efficiency is key. Giant machines do the work of hundreds, slashing project timelines from decades to years. In agriculture and construction, this is the difference between profit and loss. Extreme environments demand size. Only massive machines can withstand crushing pressure or freezing cold. Their strength and stability let them thrive where nothing else could. With fewer people willing to do dangerous work, mega machines fill the gap, taking on the risk and heavy lifting. Sometimes the problem is just so big that only a truly massive solution will do, like building tunnels, lifting oil rigs, or launching rockets. When the job is enormous, the answer is always build bigger. Meet the Bagger 293, the heavyweight champion of excavators. Over 310 feet tall, 700 feet long, and weighing 14,200 tons, it's the largest land vehicle ever built. Its job? Digging up massive quantities of earth in open-pit mining. The Bagger 293 can move over 240,000 cubic meters of material daily, about 100 Olympic swimming pools. Its giant rotating wheel, studded with car-sized buckets, scoops up dirt and rock, feeding it onto conveyor belts for processing. The process barely pauses. It just keeps chomping through the landscape. Operating the Bagger 293 takes a specialized team: drivers, engineers, maintenance crews, all working in sync. Every movement is planned, because with something this massive, even a small mistake can have huge consequences. Despite its size, it's surprisingly precise, guided by GPS, cameras, and computer systems. This precision maximizes efficiency and minimizes waste. The Bagger 293 isn't just about raw power. It's about solving massive problems with massive solutions. It's a testament to pushing engineering to its limits. Out in the fields, mega machines are the backbone of global food production. Take the Big Bud 747, the world's largest tractor. It's 27 feet long, 20 feet wide, and nearly 14 feet tall, with over 2,100 horsepower. Built for pulling massive plows across vast farmland, it's about covering as much ground as possible, fast. Modern combines harvest, thresh, and clean grain in a single pass, with headers over 50 feet wide. Fewer passes mean less fuel and more time saved during harvest. These giants are packed with tech: autopilot, GPS, onboard computers, and real-time data optimize every move. Modern planters can plant dozens of rows at once, making quick work of fields that stretch to the horizon. One operator can now do the work that once required a team. Comfort and sustainability matter too. Air-conditioned cabins, ergonomic controls, and strict emission standards. The goal: go big, go smart, and feed more people with less impact. Without these machines, modern farming wouldn't be possible. They're not just impressive, they're essential. Mega machines keep the world fed. Underground tunnel boring machines, TBMs, are quietly making history. These cylindrical giants carve out tunnels for subways, highways, and water systems, enabling cities to grow and connect. A typical TBM can be over 300 feet long and weigh thousands of tons. Its rotating cutting wheel chews through rock and soil, while the machine lines the tunnel with concrete segments as it advances. TBMs must maintain pressure, steer precisely, and handle shifting soil and groundwater, all at once. Crews monitor every aspect, making real-time adjustments underground. TBMs work where other methods can't, under rivers, through mountains, beneath cities. They've built subway systems, water tunnels, and roadways worldwide. Each tunnel is a testament to building big and thinking bigger. TBMs are innovation on a massive scale. Enter NASA's Crawler Transporter, a machine that moves rockets bound for space. Each crawler stands 20 feet tall, over 130 feet long, and weighs 2,700 tons. It moves at just 1 mile per hour, but its power is unmatched. 2 massive diesel engines drive 8 tracks over reinforced roads. The crawlers job move rockets from the assembly building to the launch pad, keeping them perfectly upright. Hydraulic leveling and constant monitoring ensure nothing goes wrong. Operators work in teams, communicating with mission control every step of the way. Every move is planned to the inch, with multiple redundancies for safety. The crawler is the unsung hero behind every rocket launch, a symbol of meticulous engineering. Sometimes the path to the stars starts with the biggest machine on Earth. At sea, engineering faces its toughest challenges: massive waves, fierce winds, and crushing pressure. Offshore cranes like the Sleipnir can lift over 20,000 tons in a single go, building oil platforms, wind farms, and bridges. Heavy lift ships sink themselves, slide under massive loads, then rise up, lifting cargo clear of the waves. On shore, industrial giants like gantry cranes and steel mill ladles move loads that would crush anything smaller. These machines are the backbone of shipbuilding, steel production, and construction. Operating them requires specialists. Every move is calculated, every load monitored, safety always first. Offshore and industrial machines are packed with tech: sensors, GPS, automation, and remote controls. Precision is as important as power. Whether building a wind farm at sea or assembling a skyscraper, these mega machines make it possible. They're the unsung heroes of modern industry. Without them, our world wouldn't function. Mega machines conquer the extremes. Building massive machines isn't just about making everything bigger. Scaling up brings unique engineering challenges. Weight increases faster than size, putting huge strain on every part. Structural strength is critical. Engineers use advanced alloys, reinforced concrete, and clever designs to handle the stress. Powering these giants takes enormous energy: huge engines, complex hydraulics, sometimes even custom power plants. Mobility is a puzzle. Tracks, massive tires, or floating platforms are all solutions, each with trade-offs. Maintenance is a challenge. Repairs need specialized crews, custom parts, and heavy equipment. Keeping these giants running is a constant battle against wear and the elements. Safety is paramount. Every system has backups and strict protocols. At this scale, even small mistakes have huge consequences. The challenges are immense, but so are the rewards. Solving these puzzles is what makes mega engineering so exciting and vital. It's innovation at its boldest. What's the real impact of mega machines? They reshape our world, literally and figuratively. These machines build the infrastructure that powers cities, connects continents, and feeds populations. Mega machines maximize efficiency, moving more earth, harvesting more crops, and transporting more material than ever before. They open up new possibilities: tunnels under mountains, bridges across oceans, farms that feed millions. Every project pushes engineering knowledge forward, leading to smarter designs and better technology. The lessons learned often trickle down into everyday life, making everything safer and more efficient. Challenges remain: environmental impact, resource use, and the need for sustainability. But these giants are symbols of human ingenuity and ambition. With enough creativity and determination, there's almost no limit to what we can build.